Okay, before we continue, we first have to define what momentum. Momentum is actually the quantity of motion. Quantity of motion. What do I mean by quantity of motion? I'll give you a scenario. There's a ball rolling down a hill, a small ball, and on another hill there's a huge ball. So this ball weighs 10 kg, this small ball weighs 5 kg. Now the next question I will ask you, if you were standing at the bottom of the hill, which ball would be much easier to stop? Oh, the obvious answer would be the smaller ball. The reason why, the smaller ball has a smaller mass, right? And the bigger ball has a greater mass. So there's a scientific term that we use in science to describe this whole motion. That scientific term is momentum. Okay? The equation of momentum is actually simple like this. So what does the M stand for? The M stands for mass, and the V stands for velocity. So if somebody has asked you, define momentum. Momentum is the product of mass and velocity. The units that I use in momentum are kg, meters per second. Okay? Right, that's the first scenario. Okay. Right. Now, let's just say we have a case whereby there's a car that is traveling towards the right, with the velocity of 10 meters per second, and its mass is, let's just say it's 500 kg. Right? And ask you, calculate the momentum of this vehicle. Simple, you write the formula P is equal to mv. You substitute your values of 500 times 10, you will get your answer as 5,000 kg meters per second. Right? And also, guys, I want you to remember that since momentum is a vector, we need to indicate direction. I like taking right as positive, I like taking left as negative, up as positive, down as negative. So my answer here will be 5,000 kg meters per second towards the right. Okay, this is one of the simple type of questions you might get. Okay, now if they say now calculate the change in momentum. So change in momentum, right? That will equal to m change in v. Okay, so now my formula now will expand in such a way it will be mv minus mu. I'll take v as final velocity, I take u as my initial velocity. So we've got a scenario. Now here's a tennis ball that has been struck against the wall. It is traveling initially u as 2 meters per second, and its mass is given as 300 grams. Okay, so and it bounces back. And they say when it bounces back, it now is traveling at a momentum velocity, rather final velocity of 1 meter per second. And the question we ask now, calculate the change in momentum of this tennis ball. Okay, first thing first, before you go to the equation, make sure all your values are in your standard units. So I see my initial velocity is in my standard units of 2 meters per second. My final velocity is also meters per second, but my mass is in grams. I have to convert this grams into kilograms. So we first know that 1 kilogram is equal to 1,000 grams. So I'm looking for kilograms. I take this, apply my cross multiplication. I'll get something that looks like this: 1,000 is equal to 300. Because I'm looking for mass, I'll divide both sides by 1,000. Divide both sides by 1,000. I'll end up getting a mass of 0,3 kg. So since I've converted my units, I can now go straight to my equation. So you saw that it's mass times velocity minus mass times initial velocity. So I'll continue writing here. So 0,3 times my final velocity, which was 1, right? Minus mass also 0,3 times initial velocity, which was 2. Right. So now I have to check if my velocity is written properly by looking at the direction. So we saw the initial velocity was going towards the right. So it is positive. My final velocity was going towards the left. So it has to be negative. So I put a negative there. So we have 0,3 minus times negative 1 will give you negative 0,3, right? 0,3 times 2 will give you 0,6, and then we compute this, we'll get an answer of negative 0,9 kg meters per second. So there is no negative momentum. The negative only indicates the direction. So I'll go on and say now 0,9 kg meters per second, and since it's negative, we know negative is to the left. So this is how I answer such questions. If it's asked me, calculate the change in momentum. The first case is the question that was asked was calculate the momentum. Okay. And then the last example, I'm going to make a scenario involving two objects. So let's just say we've got a car. We've got a car. And we've got a second car. I'll name this car, first car as A, and the second one is B. This is say it has a mass of 500 kilograms again, and the second one has a mass of 600 kilograms. This first car is traveling towards the right with initial velocity of 10 meters per second. The second one is also traveling towards the right with initial velocity of, let's just say, 5 meters per second. Okay, so this is the first part of my question. So I'll name this part as before any collision, right? And then it happens that my second part, the two cars, in my second scenario, we find that car A has now collided with car B in such a way that they actually have joined. So I'll name this scenario as after. Okay, so what do we do here? So what I like doing when dealing with such equations, I like to write out the data that has been provided by the scenario. So I'll write down MA, MB, so the mass of car A, the mass of car B, the initial velocity of car A, the initial velocity of car B, the final velocity of car A, and the final velocity of car B. So we write our data out. Okay, the mass of car A is 500 kilograms, the mass of car B is 600 kilograms, the initial velocity of car A is 10, the initial velocity of car B is 5, but we realized that in our problem that was given, we weren't given the final velocity of either car A or B. But now one has to listen. If two cars are joined together, do you think they'll be traveling in different velocities or the same velocity? And the answer will be the latter. We'll be traveling in the same velocity because they are joined. So we won't have velocities of car A or car B. We'll just have one velocity for these two cars are joined. The other thing that's going to also happen in this scenario is that the masses are also going to be added. So now this is the equation that our guys introduced you in. So there is momentum before and momentum, the momentum after. Okay? So we know before we had initial velocity and after the final velocity. So now our formula will change to ma ua plus mb all equal to ma va plus mb vb. But now, since after collision the cars have joined, I can now change this formula. Instead, write one velocity, and there will be m, the mass of car ma plus the mass of mb. And then here, everything remains the same. Right. Right, so now I'm going to substitute all the values in this equation. I'm just going to write this up here. So the mass of car A, there is 500. Initial velocity of car A, which was 10, plus the mass of car B, which is 600, times the initial velocity of car B, which was 5, will equal to final velocity m. V is equal to m plus 8. There will be 600, rather 500 plus 600. Okay, so these are all the units that I have. So I add all this up on the left hand side. So 10 times 500 will be 5,000. And 5 times this, 75, that's 3,000. 500 plus 600, that will give me 1100, which is 1,100. I'm going to add this 2 on my left hand side. So 5,000 plus 3,000, that will give me 8,000. And then V. Since I'm looking for V, I'll divide both sides by 1,100. So they can cancel. And in the end, I'll have something that looks like this. Right. Guys, at this point here, I don't have a calculator with me, but the answer is going to come out, it's actually going to come out positive. So meaning, these cars, after they collided, they continued in the original direction, which was towards the right. So we're going to say, sometimes there might be other cases. Okay. So your answer here will either come out positive or negative. If the velocity is positive, we know we'll say towards the right. In this case, if my velocity came out negative, I would then say towards the left. Guys, I came to the end of the first tutorial regarding momentum. We still have to speak about elastic and inelastic collisions where momentum is actually conserved. But for this tutorial, I'd like to end here and I'll continue with other tutorials, other topics in the future. Thank you.